Okay, let's look at an equation where the a is -1. That's different from the one we just did before. When you see a negative sign in front of the x squared, we would call that a -1. And this process is very similar, just there's one difference in the way that we're going to find our 5 points on this parabola. So again, following this pattern, A in front, B, and then the C, we're saying A is -1, B is +4, and C is +5. And again, notice the A is negative. So it's going to be, it's going to be mostly similar, but a little bit different. Plotting the first point is just the same as when A is 1. The y-intercept is just the C. Okay? This is not going to change. So the C is +5, and so let's put our point on the y-axis at +5. And points 2 and 3 are going to be, again, the x-intercepts. Now, here's where it's a little bit different. The x-intercepts should be found by first factoring out a GCF of -1. So what do we mean by that? I'm copying this equation over again, this part of the equation. Okay? When you factor out -1, you're putting -1 outside these parentheses, and inside the parentheses, you're going to copy this exactly as you see it, except you're changing the signs. Notice how the positive becomes negative, and this positive will also become negative. Okay, so I'm going to repeat that down here. X squared minus 4x minus 5. The -1, if you were going to distribute it, you don't have to, but if you distribute it to here, and to here, you'd get exactly what we started with. And that's the idea. So now what you see in the parentheses is different now than the original equation. But this is easier to factor. It's easier to factor when x squared doesn't have a negative in front of it. Okay? So factor what's in the parentheses. This does not change your A, B, or C. Our A, B, and C are still the same as what we originally wrote. But if we factor this, then what we're doing is putting -5, which is our C up top, and -4, which is our B on the bottom. And here, we know we're going to have different signs because we have a negative that we need to multiply to. And our answer, and these have to add to -4. So I'm thinking +1 and -5. Okay, these multiply to -5, but they add up to -4. So these are the numbers we're going to put into our factors. X plus 1, x minus 5. And when we set these factors to 0, that means we're looking inside each factor, as we did before, and saying, hey, what x would make this whole thing 0? And your answers are going to be, well, if x was a -1, that would make this 0. If this x was a +5, that would make that 0. So these are our x-intercepts. So let's go ahead and plot those. -1 and +5. Last, we're going to find the vertex. This is just the same as before. The B, A, and C, they don't change. They're still the same. So our B is 4, and our A is -1. So if our B is 4, then negative b must be negative 4. And if our a is negative 1, we're saying 2 times negative 1. And that means we have negative 4 over negative 2, which is what? Negative 4, negative divided by negative is positive. 4 divided by 2. Okay, just making sure I had the A, B, and C right. So our x is going to be 2. So this is not the vertex I'm about to draw, but I just want to see if the 2 is exactly in between, perfectly in between the two x-intercepts, and it is. It is. But we just need to know the y of the vertex so we can plot an actual point somewhere and not just a line. This is called the axis of symmetry. And that's just a line, but we need to know a point. So how do we find the y of the vertex? Insert this x into the original equation, the original, not this one that we did just for the x-intercepts. The original equation was, and it was a negative 1 negative times x squared, negative x squared, and our x is 2, but we got to put that x in parentheses and then square it. This is very important. Don't put this negative into here. The negative is outside of the x. If you look at the original equation, let me just erase this a little bit and try it. Do it again. The original equation was y equals negative x squared plus 4x plus 5. So we've got to take the x, which was 2, and square it before we make it negative. That's why it's important to put it in parentheses. So I put the x, which is 2, in parentheses, plus 4x, which is 2. Again, keep that in mind. X is 2 for this, plus c, which is 5. Okay, put all this in the calculator, and we get a y. If you do this carefully in the calculator with the parentheses in the right place, it should come out 9. So the y is 9. The vertex will be 2, 9. And so we already knew the x was 2. We just needed to know how high does it go? Where does the point go? From x is 2 all the way up to 9. Okay. Using our axis of symmetry here, we can mirror this point and say, well, if it was 2 away from the middle on that side, there's got to be a point over here that's 2 away from the middle on this side. And when we connect this up, we will get an upside down U. And it looks beautifully symmetric on both sides. So here's another little tip. When you do a parabola, graph a parabola where A is 1, the shape is going to be like this. The sides of the U will point up because A is positive 1. When A is negative 1, look for a shape where the arms of the parabola point down like this. Okay? When A is negative 1, the arms go down. When A is positive 1, the arms go up.